Kirchhoff's current law states that all current is conserved in a closed circuit, yielding these equations stating that the sum of the currents through a node given positive and negative direction must equal 0, or the currents coming into a node must equal the currents coming out of a node. Firstly, we need to know what current is. Current is the flow of electrons through a conductor. The electrons have charge, therefore current is measured as the amount of charge through a point per second. 1 coulomb per 1 second is also known as 1 amp. Next up, we need to know what a node is. A node is a point in a circuit where two or more components of the circuit are joining. Then we should all know what a resistor is. A resistor stems the flow of current in a circuit, and therefore it's a component in the circuit. So what we have here is an analogy to help us with the visualization of electron flow through a circuit. The electrons can be visualized as water. The stream is pushed by a pump, which is a voltage source. When the flow gets to a fork, the flow splits into two, but more water goes through the path of least resistance, which is the 6 centimeter hole, although water still flows through the 4 centimeter hole. The same amount of water then meets up before the pump, and therefore no water is lost, just like current is conserved in KCL. This first problem is really easy. It's just part of a closed circuit. We want to find the total current coming in, which should equal the total current going out of all three. So add them together, add I1, 2 amps, I2, 4 amps, I3, 6 amps, which gives us 12 amps all up. IT equals 12 amps. In this problem we have 3 resistors, a 1 ohm, a 2 ohm and a 3 ohm resistor, all connected in parallel, connected to a 10 volt power source, meaning that the voltage across each resistor will also be 10 volts. Using Ohm's law, we find the current across each resistor, and then using Kirchhoff's current law, we add them together, 10 amps, 5 amps, 3.3 amps, giving us 18.33 amps. And then we verify this using the total resistance way of finding IT, and it also gives us 18.33